Bonding. Describe 3 key characteristics of ionic compounds. Conduct electricity when molten/dissolved, not when solid. High melting point, strong ionic lattice, held strong by a strong electrostatic force of attraction. Dissolve in water, the water molecules are polar. With water molecules being polar mean, part of a molecule has small positive negative charge, part of a molecule has small positive charge, charged parts pull the lines away from lattice, therefore dissolves. Molecules are held together by strong covalent bonds, and a single covalent bond contains a shared pair of electrons. Giant covalent structures have strong covalent bonds. Each carbon atom forms 4 strong covalent bonds. Structure of graphite. Weak bonds between layers. Sheets slide over each other, hence uses a dry lubricant in pencils. Layers are quite far apart compared to length of covalent bonds, so low density used. Therefore is used low density, therefore is used in tennis rackets. Insoluble in any solvent as strong covalent bonds. Delocalized electrons which are free to move to carry a charge, therefore is a good electrical conductor. But the main one really is the weak bonds between layers and sheets slide over each other. Therefore is used as dry lubricant in pencils. Structure of diamond. Vibrations travel easy through stiff lattice, good thermal conductor, insoluble in any solvent, each carbon covalently bonded to 4 carbons in its tetrahedral shape. Dative covalent bonding, where both electrons come from one atom. An example is NH4 plus ammonium ion formed when nitrogen and ammonia donates a pair of electrons to a H plus ion. Both electrons come from one atom. Charge cloud, an area where you have a high chance of finding electron pair with around the charge cloud and affects how much charge cloud repels other charge clouds, shape of the charge cloud. 3 types of angles between charge clouds, strongest to weakest. Lone pair angles are biggest, lone pair bonding pair angles are second biggest, bonding pair angles are smallest. How do you use number of electron pairs to predict shape of molecule? So we work out the central atom. So let's say we have Cl4, the central atom is obviously going to be carbon. Work out the number of electrons outer shell of central atom carbon, which is 6. Add 1 for every atom, so it's 4 atoms, so 10. Divide by 2 to find the number of electron pairs on the central atom. To find electronegativity, the atom's ability to attract the electron pair in a covalent bond. What happens in a covalent bond between 2 atoms of different electronegativity? Bonding electrons is pulled towards a more electronegative atom, therefore you have a polar bond. And why is in a covalent bond between 2 atoms of the same element non-polar? Because atoms have equal electronegativities, therefore electrons are equally attracted to both nuclei. Definition of a dipole: a difference in charge between 2 atoms caused by a shift in electron density in the bond. Dipole: a difference in charge between 2 atoms caused by a shift in electron density in the bond. What happens to changes in a non-polar molecule? Positive and negative charge spread evenly across the molecule. What does difference in electronegativity between 2 atoms in polar bond cause? Permanent dipole. What do polar molecules have? They have permanent dipole forces. State key fact about molecules with permanent dipoles. The weak electrostatic force of attraction between delta positive and delta negative charges on a neighboring molecule. A key fact about intermolecular forces, much weaker than covalent and ionic and metallic. 3 types of intermolecular forces and was iodine. Induced dipole forces, permanent dipole caused by polar molecules, hydrogen bonding. Iodine is solid at room temperature. 2 key characteristics of iodine. We already decided it's solid at room temperature, but it's also the atoms are held in pairs by strong covalent bonds, forming iodine molecules, and molecules are held in molecular lattice by weak van der Waals forces. Key difference of shapes of molecules and strength of van der Waals forces. What do large molecules have? Long, straight molecules are closer together than branched ones, therefore they have stronger forces between them, stronger van der Waals forces between them, and larger molecules have larger electron clouds. What happens when you boil a liquid? When you boil a liquid, you need to overcome the intermolecular forces so particles can escape from liquid surface. When you boil liquid, particles need to overcome the intermolecular forces so particles can escape from liquid surface. Another thing, physical properties, van der Waals can affect viscosity, thickness of fluid. Hydrogen bonding. An attraction between the electron deficient hydrogen atom of one molecule and a lone pair of electrons NOF atom on a neighboring molecule. What do non-polar molecules have? Small temporary dipoles. Define molecule: a group of atoms joined together by covalent bonds. Say key fact about when a molecular substance turns into a gas: only intermolecular forces are overcome, not bonds. What happens when water freezes? Water molecules are not free to move, therefore hydrogen bonds form permanently. What happens when liquid water cools to form ice? Molecules make more hydrogen bonds arranging into regular lattice structure. Molecules are further apart than molecules of liquid water. Ice is less dense than liquid water. Metallic bonding. Positive metal ions attracted to delocalized negative electrons, forming a lattice of packed positive ions that see delocalized electrons. State how positive metal ion is formed. Outermost shell of electron of metal is delocalized. The electrons are free to move. And delocalized melting point. The moment of delocalized electrons per atom affects the melting point. So yeah, the outermost shell of electrons of metal is delocalized. Therefore, electrons are free to move. 3 key characteristics of metal when it happens when you melt / boil a simple covalent compound. Metals are insoluble except liquid metals, strong as metallic bonds. Delocalized electrons pass kinetic energy to the metals, therefore they're good thermal conductors. And when you melt a simple covalent compound, you only have to overcome the intermolecular forces that hold the molecules together. You do not have to overcome the bonds. What you don't have to break the covalent bonds. You only have to overcome the intermolecular forces. This is really important stuff now. The solubility of substance of water depends on the type of molecules it contains. What is water? Water is a polar solvent and 2 types of substances, and it dissolves. Substances that are charged, polar, dissolve well. Substances that are uncharged, non-polar, do not dissolve well. But yeah, remember, you don't have to overcome the bonds, you only have to overcome the intermolecular forces.